The third topic is social media and user-generated content. I'm going to introduce two articles. One is The Informational Value of Social Tagging Networks by Hyo-ryung Nam and PK Kannan. And the other is Advertising Content and Consumer Engagement on Social Media, Evidence from Facebook by Do-kyun Lee, Kartik Hosanagar, and Harikeshi Nair. This article focuses on a user-generated content, social tagging. Social tagging is a new way to share and categorize online content that enables users to express their thoughts, perception, and feelings with respect to diverse concepts. It is defined as a user behavior that results in user-defined keywords reflecting the user's own interpretation of the content. This is an example of social tags. The authors of this article used the data from Delicious, which is a personalized bookmarking service. A user can add a bookmark of a website with her own text as in the first figure, figure 2 panel A. The figure in the center illustrates the text linked to Google. The size of the bubble represents the popularity of the tag, captured as the volume of bookmarks. The thickness of the link represents the associative strength between the site and the tag. Some tags are connected to multiple sites like software and technology in figure 3. Those tags are connected to Apple, Microsoft, as well as Google. This article studies this network structure of social tags. Especially, this article investigates the effect of social tagging on the firm values, which is measured by investors' stock responses. This table summarizes the variables used in analysis. The network features are measured through three types of variables. First, brand familiarity. The volume of bookmarks and the number of popular tags connected to the site are used to measure the brand familiarity. Second, favorability of brand associations. This is measured by the volume of positive tags and the volume of negative tags. Third, comparative overlap of brand associations. This is measured by conceptual metrics of association strength based on the volume of bookmarks for each keyword site pair. The authors relate those network characteristics to unexpected portion of stock returns. This is the model to be used in analysis. The left-hand side is the unexpected return, which is defined as the deviation of actual stock return from the expected return. The dependent variable is a return variable, which is the first-order temporal difference in the stock price. Therefore, the right-hand side should be also differenced, so it has the difference in accounting variables, control variables, and the social tagging variables. And this model is just a regression model. From the results, the authors found that social tag-based metrics has explanatory power for the unanticipated stock returns. Specifically, it is important for strong brands to enhance category dominance, that is, connection to the category's core associations. For example, software, technology, internet. Those tags would be core associations for the IT industry, so Google have to enhance the connections to those tags. And it is critical for weak brands to enhance connectedness. That is the extent to which competitors share an association with the brand. For example, for a small IT company, it would be critical to share tags as many as possible with Google, Apple, and Microsoft. The next article is fascinating because the authors use machine learning techniques to extract valuable information from text messages, as in Bushkan's and Allenby's article, and relate the information to consumer engagement responses. Firms are utilizing social media as an advertising channel. In social media, consumers express their engagement with the firm by various actions, including liking the ad, posting a comment, sharing the ad with friends, and entering the firm's website by clicking the ad. The authors focus on the effect of ad content in social media on the engagement. To do so, the authors collected ad message data from Facebook, which is the biggest social media in the world, and they developed a supervised machine learning technique to label the content in the ad messages. This is an example of labeling the content. The left-hand side shows sample messages from Walmart, and the right-hand side shows the content tags that the machine learning algorithm extracts from the messages. Then, those tags and various characteristic variables of ad content are used to predict the engagement responses. Conceptually, the model is an aggregate logistic regression, which is a variant of regression. But the Facebook's page system strategically selects users for the messages. So without consideration of the Facebook system, the estimation may suffer from selection biases. Thus, the authors developed a copy of the Facebook system and applied it to the data before the final analysis. From the research, the authors found that the inclusion of widely used content related to brand personality, such as humor and emotion, is associated with higher levels of engagement. Directly informative content, such as price and deals, is associated with higher engagement levels in combination with brand personality-related attributes. Even after incorporating Facebook's own algorithm, the results still persist, implying that the content strategy based on the findings above may still benefit. So far, I have introduced 7 studies where the new type of data was used in analysis. While some of the articles used the cutting-edge machine learning technique, the others used a variant of log-log demand model and or a regression method. Throughout the articles, you may see that a lot of online data allow for analysis we couldn't do before. And now it's your turn. In Kannan, I uploaded abstracts of the articles introduced. Please carefully read the abstract and pick one of the article. Then, read the article. All articles are available in Kannan. Some technical parts, like mathematical equations, would be hard to understand, but it's okay. You can skip the technical parts. You just need to understand the research questions, the main idea to address the questions, and what kind of data were used to show evidence. Then, write a short 1 or 2 pages of your own research proposal using the method in the article. The proposal does not need to contain mathematical models. It should clearly deliver what is research question, what is the idea to address the question, and what kind of data you need, have, or expect to have to show empirical evidence from data. Alright, that's all I have for this lecture, and see you, bye bye!